Hello, I welcome you once again into Kenya Mathematics Classroom. On this episode, we are going to look at a continuation of part 4 of the rational functions. If you remember, in our test presentation on rational functions, we were solving some questions and we were left with the fourth question. And we were asked to simplify this in partial fraction. That is 5x plus 4 over x minus 1, x plus 2 all squared. So, in trying to solve this problem, we have 5x plus 4 all divided by, we have x minus 1, and we have x plus 2 all squared. So when you look at this expression, realize that this is denominator with a repeated factor. And so with this, the partial fraction will be a over, or let's see how best we can solve this problem. So 5x plus 4 over x minus 1, x plus 2 all squared. The first one is a linear factor, and the second one is a repeated factor. So this will be a over x minus 1, then it will be over the factor you have in the bracket is x plus 2, then plus c over the whole factor, that is x plus 2 all squared. And so a step down, you are going to have 5x plus 4 all divided by x minus 1, then you have x plus 2 all squared. So we try to find the least common denominator, and it will be equal to what we have on the left. So that is x minus 1, then we have x plus 2 all squared. So we have x minus 1 in here, then we are left with this, and that is x plus 2 all squared times a. So we have a times x plus 2 all squared plus, then x plus 2 will go in here, and we are left with one of the x plus 2 because we have x plus 2 all squared. So this here, we are left with x minus 1, then x plus 2. So b will multiply x minus 1, then x plus 2, then plus, then c will also go in here, then we are left with x minus 1. So x minus 1 will multiply c. So we have c times x minus 1. So you realize that the denominators on the left and the right are the same. So we can equate the numerators. And equating, we have 5x plus 4 equals a into bracket x plus 2 all squared plus b, then we have x minus 1, we have x plus 2, then we have c, then we have x minus 1. So we are now going to solve for a, b, and c. Now when we look at this identity, you realize that when we put x equals 1, then 1 minus 1 will give us 0 here. So 0 times the b times x plus 2 give us 0. And 1 minus 1 also give us 0. So 0 times c will give us 0. So we are left with a. And so a step down, we are saying that x should be equal to 1. So we are going to have 5 times 1 plus 4 equals a into bracket 1 plus 2 all squared. Here we have b 1 minus 1, then we have x plus 2, then we have c 1 minus 1. So take note that because of the 1 minus 1, which is 0, 0 times x plus 2 times b will give us 0. So b is gone. Then 1 minus 1 is 0. 0 times c is c, so c is also gone. So we can find the value of a. Now, 5 times 1 is 5, plus 4 will give us 9 on the left-hand side. So we have 9 on the left-hand side is equal to 1 plus 2 is 3, and 3 squared will give us 9. So 9 times a will give us 9a. Now, dividing through by 9, then we can say that a is equal to 9 into 9 is 1. So the value of a is equal to 1. Now, we take the identity again, and the identity is 5x plus 4 is equal to a. We have x plus 2 all squared plus b. We have x minus 1. Then we have x plus 2 plus c. Then we have x minus 1. Okay, so here we can also put x to be equal to minus 2. Now, when we put x equals minus 2, realize that minus 2 plus 3 give us 0. So 0 times x minus 1 times b will give us 0. Then minus 2 plus 2 also give us 0. 0 squared is 0. 0 times a is 0. So we can find the value of c. Now, in doing that, we have 5 in the bracket. We have minus 2 plus 4, and this will be equal to, take note that the minus 2 plus 2 will give us 0. So 0 squared is 0 times a will give us 0. So the a is gone. Then the minus 2 plus 2 will give us 0. 0 times x minus 1 times b will also give us 0. So b is also gone. Now we have c into bracket minus 2 minus 1. So 5 times minus 2 will give us minus 10. We have plus 4 equals minus 2 minus 1 is minus 3. So we have minus 3c. So we have minus 3c. Now minus 10 plus 4 will give us minus 6 equals minus 3c. Dividing through by minus 3, then we can say that the value of c will be equal to 2. That's the negative, will cross out the negative, and 3 goes into 6 2 times, so c equals 2. Now we know the value of a to be equal to 1, the value of c to be equal to 2. So we write the same identity again. And when we write the same identity, we now put x to be equal to any value at all, so that we'll be able to find the other alphabet. Now we know the value of a to be equal to 1, and we know the value of c to be equal to 2. Now we write the identity again. And the identity is 5x plus 4 is equal to, we have a into brackets, we have x plus 2 all square plus b times x minus 1. Then we have x plus 2, then plus c times we have x minus 1. The same identity. Now we can put x to be equal to 0. We can put x to be equal to 0 because the value of a is 1, the value of c is 2. So putting x to be equal to 0, 5 times 0 is 0. 0 times 4, we have 4 on the left-hand side. 0 plus 2 is 0. 2 squared is 4. 4 times a will give us 4a. Then we have b. 0 minus 1 is minus 1. 0 plus 2 is 2. Then c, 0 minus 1 is minus 1. So we simplify. We have 4 on the left equals 4a. Minus 1 times 2 is minus 2. So minus 2 times b is minus 2b. Then c times minus 1 is minus c. Now by substitution, we know that the value of a is 3. The value of a is 1. So 4 times a will be 4 times 1. Minus 2 times b. B is not known. Minus c. And the value of c equals 2. So we try to solve for b. We try to solve for b. And in solving for b, we have 4 on the left. 4 times 1 is 4. Then we have minus 2 here. Then we have minus 2b. 4 equals 4 minus 2 give us 2. Minus 2b. So by simplifying, minus 2b on the left-hand side becomes 2b on the left. Minus 2b on the right-hand side becomes minus plus 2b on the left-hand side. Then already we have 2 here. Then 4 also becomes minus 4 on the right-hand side. So if you have 2b to be equal to 2 minus 4 is minus 2. So we divide through by 2, then the value of b is equal to minus 1. So in all, we have seen that the value of a equals 1, the value of c equals 2, and the value of b is equal to minus 1. So when you are given the identity, when you come out with the identity, when you simplify and you come out with the identity, you now look for values of x that you can put in such a way that some of the variables will be eliminated or the alphabet will be eliminated so that you can find the other. And so that is how we solve such problem. Now, in solving for that, we can now write the partial fraction. Don't forget that we were given 5x plus 4. That is 5x plus 4 over, we were given x minus 1. Then we have x plus 2 all squared to simplify. And we said that it will be a over x minus 1 plus b over x plus 2, then plus c over x plus 2 all squared. So now the value of a equals 1. And so a will be 1. The value of b equals minus 1. And the value of c equals 2. So by substitution, we are going to have, by substitution, we are going to have 5x plus 4 all by x minus 1. We have x plus 2 all squared. This will be called a over, and a gave us 1. So 1 over x minus 1 plus b. And b is minus 1, so it will be minus 1 over x plus 2. Then plus c, and c is 2, so it will be 2 over x plus 2 all squared. So this is the partial fraction. So if we're asked to express 5x plus 4 over x minus 1, x plus 2 all squared in partial fraction, the result is what you see there. So When you simplify and you get the identity, then you now put values of x in such a way that you can find some of the variables or the alphabet. Then in all, you are getting all the alphabet involved. So a give us 1. That is why instead of a over x minus 1, we have 1 over x minus 1. Then b gave us minus 1, and that's what we have done there. Then plus c, and c also gave us 2, and that's what we have there. So this is denominator with a repeated factor. This is denominator with a repeated factor. Now, we are going to look at how best we can solve this problem. We are going to take a look at another problem and see how best we can solve that. So for now, we have been able to solve questions on denominator with a linear factor, denominator with a quadratic factor, and now we have seen how to solve questions on denominator with a repeated factor. So now we are going to look at 1 or 2 questions and we see how best we can solve that. Now, assuming we are given to express 2x squared minus 4x plus 3 all divided by x minus 2, then we have x plus 1 in partial fraction. Okay, so now this is the problem we are given, and we are asked to express 2x squared minus 4x plus 3 all by x minus 2, x plus 1 in partial fraction. Now, when you look at this, when you check the denominators, you think that it's a linear factor. It is a linear factor, all right, because all these factors are linear. But when you check the degree of the numerator is 2. That's the highest exponent of the variable is 2. And when you look at the denominator, when you multiply the 2 factors, it also gives us a term in x squared. So because the degree of the numerator is equal to the degree of the denominator, then this is improper fraction. So what we do is, we are now going to multiply our x minus 2 by x plus 1. Then x times x will give us x squared. X times plus 1 will give us x. Minus 2 times x will give us minus 2x. Then minus 2 times 1 will give us minus 2. So in all, we are going to have x squared minus x minus 2. So now when we multiply these 2 factors, this is what we are getting. So with the improper fraction, we divide the numerator by the divisor. That is the denominator. That is what we are going to do over here. So instead of 2x squared minus 4x plus 3 all by x minus 2, x plus 1, we have now multiplied this by this, and this is what we are getting. And so we are going to divide this by this and see what our results will be. Now, we have x squared minus x minus 2 as our divisor, and our dividend is what we have up here. That is 2x squared minus 4x plus 3. Now, we start with the division. Now, when you refer to my presentation on polynomials, you understand what I'm going to do here. You appreciate the division of polynomials. So, 2x squared divided by x squared will give us 2. Then 2 times x squared will give us 2x squared. 2 times minus x will give us minus x. 2 times minus 2 give us minus 4. Then we subtract this from this. So, we have our minus and our bracket here. So we have 2x squared minus 2x squared. That will give us 0. Then minus 4x minus minus x. So minus minus x will give us plus x. So minus 4x plus x will give us minus 3x. Then 3 minus minus 4 will give us plus 7. That means that when we divide 2x squared minus 4x plus 3, all divided by x squared minus x minus 2. Don't forget that the x squared minus x minus 2 is the same as the x minus 2 times x plus 1. We multiplied before we had this quadratic expression. So dividing this by this is the same as dividing this by this. And the result, you know, is the quotient. That's the quotient. So 2 plus the remainder. The remainder is minus 3x plus 7. This can be written as 7 minus 3x. It's the same thing, all divided by the divisor. And the divisor is x squared minus x minus 2. And so when you divide 2x squared minus 4x plus 3 by x minus 2x plus 1, the result is giving you 2 whole number plus the remainder is 7 minus 3x, all divided by the divisor again. So we are now going to solve this problem. And when you look at this problem, now you can see that the degree of the numerator is 1 and the degree of the denominator here is 2. So this is a proper rational function. And when you look at this, we have to take this back into the original factor, the 2 factors form. And so this can be expressed as 2 whole number 2 plus 7 minus 3x, or divide, instead of the quadratic expression, you are going to have x minus 2, then we have x plus 1, x minus 2, x plus 1. So when you look at this, this is denominator with a linear factor. So we are back to the first type, that is denominator with linear factors, and the factors are all linear. So we now simplify this, and whatever we are getting, we add it to 2, and that will be the answer. And this is how we solve problems. This is how we solve improper fraction problems in improper fraction. So you take note of that. So when you check and you see that the degree of the numerator is equal to the denominator, or the degree of the numerator is greater than the degree of the denominator, then it means it is impartial fraction, and therefore you have to divide by the divisor, and whatever you are getting, finally you have to convert it back, because when you look at this, it's now denominator with a linear factor, but because of the plus 2, we have to solve this. Whatever we get, then we add it to the 2, and that will be the result for that. So that will be improper. This is an example of an improper fraction. So we are now going to solve for 7 minus 3x. That is 7 minus 3x divided by, we have x minus 2, then we have x plus 1. So this is now a linear factor. So it will be a over, the first linear factor is x minus 2, then plus b over, the second one will be x plus 1. So the same way we solve denominator with a linear factor, that's the same approach. We find the least common denominator, that is x minus 2, then we have x plus 1. So this here we are left with this, and this times a will give us a times x plus 1, then plus b. This here we are left with this, so it is b times x minus 2. Now the denominators are the same, so we equate the numerators, and the numerator here is 7 minus 3x equals a, then we have x plus 1, then we have plus b, we have x minus 2. So we now put x to be equal to values. Now when we put x equals to 2, 2 minus 2 gives us 0, so b will be gone. So we have 7 minus 3 times 2 equals a into bracket 2 plus 1 plus b into bracket 2 minus 2, and 2 minus 2 gives us 0. 0 times b is gone. So we have 3 times 2 is 6. 7 minus 6 is 1. Then 2 plus 1 is 3. 3 times a is 3a. So when we divide both sides by 3, then this is gone. So the value of a will be 1 over 3. The value of a will be 1 over 3. So you write the identity back again. You write the identity back again, and the identity is 7 minus 3x equals a into bracket x plus 1 plus b into bracket x minus 2. Then we now put x to be equal to, this time round, let's take minus 1, because minus 1 plus 1 gives us 0. So a will be eliminated, so we can find the b. So we have 7 times 3 times minus 1 equals a minus 1 plus 1 plus b, you have minus 1 minus 2. So 7 minus 3 times minus 1 will be plus 3. So 7 plus 3 here will give us 10. Then minus 1 plus 1, 0 times a is 0. Then minus 1 minus 2 is minus 3 times b. That's minus 3b. So we divide both sides by minus 3. Then our b will be equal to 10 over 3. Then our b will be equal to 10 over 3. B will be equal to 10 over 3. So now we now simplify. Because you realize that when we divided the dividend by the divisor, we had 2 plus 7 minus 3x over x minus 2x plus 1. And now solving for these alone, that is denominator with a linear factor, we are getting the value of a. A now is 1 over 3, and b now is x plus 1. And b now is 10 over 3, and a is 1 on 3. And therefore, it means that 7 minus 3x over x minus 2 x plus 1 is equal to a, and a is 1 on 3 all by x minus 2 plus b, that is 10 on 3 all by x plus 1. But don't forget that from the question you were rather given 2x squared minus 4x plus 3, all divided by x minus 2, then x plus 1. And by division, we have 2 plus. Now we have been able to solve this. So this will be 1/3 over x minus 2 plus 10 over 3, all by x plus 1. So this is the partial fraction. This is how we express this in partial fraction. And this can be simplified further as 2 plus 1 on 3 times x minus 2 plus 10 on 3 times x plus 1. So when we are asked to express this in partial fraction, this is the final answer. So take note, because this was improper fraction, that is why we multiplied the two factors and we divided this by this. And we have 2 plus 7 minus 3x over the divisor. And after solving for this, the a gave us 1 on 3 and b gave us 10 on 3. And so from the division of polynomials, we have 2 plus a over that plus 10 over this. And now a is 1/3 and b is 10 over 3. And so we simplify, and this is what we are getting. So that is how we solve problems with improper fractions. That is when the numerator, the degree of the numerator, is equal or greater than the degree of the denominator. That is how we solve problems like that. So that will be all for now on this particular episode. Thank you.